Hello and welcome to Add-on. So, the question is represent the following function by a Fourier sine series and the function is t in an interval 0 to pi by 2 and pi by 2 in an interval pi by 2 to pi. That is, हमें function given है f of t is equal to t when the interval is 0 to pi by 2 and pi by 2 when interval is pi by 2 to pi. So, overall interval is 0 to pi. इस क्वेश्चन को सॉल्व करने के लिए हमें याद होना चाहिए Fourier sine series for a function fx. Now, Fourier sine series क्या होता है? It is given by function f of x is equal to summation n from 1 to infinity bn sine nx and bn is equal to 2 upon pi integration 0 to pi f of x sine nx dx. This is the formula for Fourier sine series in an interval 0 to pi that you need to remember. Now, the function is given in t variable. So, हम इसे लिख सकते हैं f of t is given by summation n from 1 to infinity bn sine nt and bn is given by 2 upon pi integration 0 to pi f of t sine nt dt. So, we will be using this form जिसमें mark this as equation 1 क्योंकि final answer इसी form में आएगा. Now, to get Fourier sine series, we need to find bn. So, bn is equal to 2 upon pi integration 0 to pi by 2 f of t sine nt dt plus integration pi by 2 to pi f of t sine nt dt. Since हमें जो function given है वो 2 intervals में given है, so हमें integration को break करना होगा. Now, it is 2 upon pi integration 0 to pi by 2 function की value in interval pi by 2 थी and it is t in an interval 0 to pi by 2 and pi by 2 in an interval pi by 2 to pi. So, it is 2 upon pi integration 0 to pi by 2 f of t is t sine nt dt plus integration pi by 2 to pi, it is pi by 2 in an interval pi by 2 to pi sine nt dt. Now, solve this. We need to solve this using Bernoulli's formula, which is integration of u multiply v dx is equal to u multiply v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. जिसमें v1 is equal to integration of v with respect to dx and v2 is integration of v1 with respect to dx and so on. So using this we take u is equal to t and v is equal to sine nt जिसमें u dash is equal to 1 and u double dash is equal to 0. That is हमें u double dash के बाद इसे सॉल्व नहीं करना है, so that हमें सिर्फ v1 and v2 चाहिए. Now v1 is integration of v with dt. Since ये t के फॉर्म में है and ये फॉर्मूला हमने x की फॉर्म में लिखा है, so it is sine nt dt and integration of sine is minus cos nt divided by n. Now v2 is integration of v1 that is minus cos nt divided by n, which is equal to minus sine nt divided by n square. So this is the value for v2, this is for v1, this is u dash and this is u double dash. So formula is given by u multiply v1 minus u dash v2. हमें सिर्फ ये दो फॉर्म चाहिए. So it is bn is equal to, now हमने साइन एंटी के लिए इंटीग्रेशन फॉर्म फाइंड आउट किया था जिसमें हम u v1 and u dash v2 पुट करेंगे. So it will be 2 upon pi and u multiply v1 that is u is t multiply minus cos nt divided by n further minus u dash multiply v2 जो ऐसे होगा. It is 2 upon pi in bracket take the expansion, it is u multiply v1, u is t multiply minus cos nt divided by n minus 1 multiply u dash is 1 and v2 is minus sin nt divided by n square. इसको सेपरेट कर लेते हैं सेकेंड इंटीग्रल के साथ, तो 2 by pi मल्टीप्लिकेशन में चला जाएगा. 2 by pi, it was integration from minus pi by 2 to pi pi by 2 sine nt dt, and this limit is from 0 to pi by 2. So put the limit 0 to pi by 2. Here it is integration from pi by 2 to pi by 2 sine nt dt. Now solving this further, it is 2 upon pi minus t cos nt divided by n minus minus plus sine nt divided by n square. Limit is from 0 to pi by 2 plus 2 upon pi. Take pi by 2 out, it is pi by 2 integration pi by 2 to pi sine nt dt. जिसमें 2 से 2 कैंसिल हो जाएगा, पाई से पाई कैंसिल हो जाएगा, सो ये हो जाएगा 2 अपॉन पाई माइनस टी कॉस एन टी डिवाइडेड बाय एन प्लस साइन एन टी डिवाइडेड बाय एन स्क्वायर. लिमिट इज फ्रॉम 0 to pi by 2 plus integration of sin nt is minus cos nt divided by n, and limit is from pi by 2 to pi. Now put the limit, it is 2 upon pi minus pi by 2. Put the upper limit minus pi by 2 cos n multiply pi by 2 whole divided by n plus sin n pi by 2 divided by n square. Put the lower limit which is 0, जिसमें ये वाला पूरा पार्ट 0 हो जाएगा. Since 0 multiply sin, it is cos 0 by n plus sin 0 by n square. Now for second integral, it is plus minus cos n pi minus में minus cos n pi by 2 divided by n. Now हमें पता होना चाहिए that cos 0 is equal to 1, sin 0 is 0, and cos n pi is minus 1 raised to the power n. So using this ये होगा, it is bn is equal to 2 upon pi in bracket minus pi by 2 cos n pi by 2 divided by n plus sin n pi by 2 divided by n square minus cos 0 is 1 but multiply 0 is whole 0 minus sin 0 is 0 plus 1 upon n minus cos n pi plus cos n pi divided by 2. So it is 2 upon pi multiply minus pi by 2 cos n pi by 2 divided by n plus 2 upon pi sin n pi by 2 divided by n square plus 1 upon n in bracket minus cos n pi is minus 1 raised to the power n plus cos n pi by 2. Now इसमें 2 से 2 कैंसिल हो जाएगा, पाई से पाई कैंसिल हो जाएगा. इट इज माइनस cos n pi by 2 divided by n plus 2 upon pi n square sin n pi by 2. It is minus 1 raised to the power n divided by n plus cos n pi by 2 divided by n. Now these two terms are same, so ये cancel हो जाएंगी. This gives bn is equal to 2 upon pi n square sin n pi by 2 minus 1 raised to the power n divided by n. Now bn हम ऐसे भी लिख सकते हैं, इसको हम for even and odd separate भी कर सकते हैं, which is when sin n pi is 0. We know this. But if n is even, then sin n pi by 2 will be sin n pi form, which is also 0. So when n is even, this whole part will be 0. So हम इसे लिख सकते हैं, and one more thing, this n belongs to the integers. So when it is n pi by 2, if n is odd, then it won't be cancelled by 2. But if it is even, then it will be cancelled by 2. Then it will become an integer. Then this will be 0. And minus 1 raised to the power n is 1. when n is even, n minus 1 when n is odd. So using all this हम bn को लिख सकते हैं. bn is equal to, in two form, this whole part will be 0 for n even, and for n even this part will be plus 1, then it is 1 upon n when n is even. And when n is odd, this will remain as it is, that is 2 upon pi n square multiply sine n pi by 2 minus minus 1 divided by n when n is odd. Since when n is odd, minus 1 raised to the power n is equal to minus 1, so it is minus 1 divided by n. So finally bn is equal to minus 1 upon n when n is even, and 2 upon pi n square sine n pi by 2 minus minus plus 1 upon n when n is odd. Now bn हमारे पास आ गया है. हमें finally find out करना था Fourier sine series, which is given by f of t is equal to summation n from 1 to infinity bn sine nt, which is from equation 1. Here, this is the equation 1 जिसके थ्रू हमारे पास Fourier sine series आएगी. Now, it can be written as summation n is equal to 1 to infinity bn was 2 upon pi n square sine n pi by 2 minus minus 1 raised to the power n divided by n whole multiply by sine nt. But if we want to write it in even and odd form, this one is also right. Now, to write it in further simplified form, it is f of t is equal to summation n from 1 to infinity. In place of bn it is minus 1 upon n sine nt when n is even. For odd, it is summation n from 1 to infinity 2 upon pi n square sine n pi by t n pi by 2 plus 1 upon n multiply by sine nt when n is odd. Using this form, using this bn, हम ft को भी two parts में लिख सकते हैं when n is even and when n is odd. This is the more simplified form. So, both ways the answer is correct. Either this or this. जिसमें हमने bn डायरेक्टली लिख लिया है विदाउट टेकिंग इवन एंड ऑड टर्म, एंड नेक्स्ट हमने इवन एंड ऑड में सिंप्लीफाई कर दिया है.